So let me present to you the visual representation of Kubernetes cluster. Please pardon my poor presentation skills. I'm not good at drawing, but I promise you, when I will explain to you, it will make all sense to you. So here we have a 4-node Kubernetes cluster, 1 master and 3 worker nodes. This is a typical cluster setup. Now, I have put Docker running on each of these nodes of the cluster, one thing. The second thing is pods are running on the worker nodes. Okay, this is very important to understand. And this is the Kube API server. That is the process that is running on our master node. Now, the first thing first, I have chosen 3 worker nodes. The question is why? So the answer is you always want to have odd number of worker nodes in your cluster. Imagine you have only 2 worker nodes. If your 1 worker node goes down, your cluster stalls. So your cluster will frozen and it will not work. So you always want to have an odd number of nodes to fill the quorum of the cluster. Okay. Now here you can ask me questions. Here I have only 1 master node. What if this master node goes down? So the answer is either you leverage the AWS EKS services, Elastic Kubernetes services. What it does is AWS says that you take care of your worker nodes. I will take care of your master node, and I will actually put this in a high availability zones, so you don't have to worry about managing your master node. Remember, all these processes, components, they are part of the master node. So it means that to protect the master node is absolutely important. Okay, so either we set up our own master and have another master, so to provide the fault tolerance and high availability, or let's AWS take care of your master node, and then you work on the worker nodes where you are running the applications running in the form of containers. One thing. The second thing is the kubelet process. It runs on each of the worker node, and that kubelet process interact with your Kube API server and interact also with the other like schedulers also and the controllers. But this is how it is. On this side you have kubelet. Kubelet is not on the master node. It is on each of the worker nodes, and that interact with the master node to get stuff done in the form of applications or the pods. Okay. Now this is the master node. Kube API server, this is our Kube API server, the gatekeeper, everything, regardless of you're coming from CLI, web, or you are doing API calls, you have to interact with Kube API server. And the Kube API server talk with the etcd, like this key value store, to get the information from the configuration about your Kubernetes cluster. Okay, then we have a kube proxy. Kube proxy, like I said, it runs cluster wide, and it has to do with the nodes interconnection, node interconnection communication. Okay, we have a etcd running on here. You should have a multiple copies of etcd, or you should be taking the snapshots if your cluster need to be restored. We will talk more about in the etcd section. We have a cron jobs. You can have a similar like we have in Linux cron job. We can have a cron job API server. Other than this stuff, we have namespaces, secrets, volumes, users, services, deployments, ingress rules, and the limits on the pods. So we will create these Kubernetes objects that will be part of our cluster. So this is the overall Kubernetes cluster architecture, just a visualization of the cluster, what it look like. And now it does not matter you have a 4-node cluster, you have a 1-node cluster, all these services, all these components must be running on each of these nodes. So let's go ahead and explore each of these in further, but I wanted to give you a visual representation of our Kubernetes cluster.